Anyways, polynomial functions, day 2. All right. This is going to be more of the graphing parts of things. All right. This video, this PowerPoint is going to be different than what is on Schoology as far as the PowerPoint you're following with. So don't follow along, basically, is what I'm saying on there. So here we go. First off, a couple definitions we need to know. You've probably heard these words before. I don't know if we put definition to them or not, but now we are. First one is degree. Your degree of a polynomial is simply, it's the value of the largest exponent. Okay? Whatever your biggest exponent is in a polynomial function, that is considered your degree. All right? The leading coefficient is whatever is the coefficient that is attached to that degree. All right, so let's say, let me write one up here real quick. Let's say the polynomial we're working with is 3x to the 4th plus 7x to the 3rd minus 2x squared plus 8x minus 3. All right. Your degree is your biggest exponent. So if you look at your exponents, you have 4, 3, 2, 1, and none. So your degree would be 4. Okay, so your degree is your biggest exponent. So degree of 4. Your leading coefficient is the number that's attached to that exponent, which would be 3 from right here. They all come from that first term. Okay? Now, here's what you guys are going to do today. We are going to look at 4 different graphs, and we are going to assess and look at how your degrees and your leading coefficients affect the shape of a graph. Okay? And that's what the part down below basically says. When you're given a graph, degrees are usually classified as being either odd or even. Okay, so there's one type of shape when you have odd degrees, there's one type of shape when you have even degrees. Leading coefficients are classified as being positive or negative. Each one of those affect your graph in a different way also. That's what we're learning today. We're going to figure out what your graphs look like when they're odd degrees, what they look like when they're even degrees, and then whether you have a positive or negative leading coefficient, how that affects the graphs. Okay, so it's going to kind of go back to what we did a few chapters ago in chapter 2 when we had end behavior, when we said, you know, as x increases, the graph increases, as x decreases, the graph decreases, stuff like that. But we're not going fully back to that. Okay, so here's your 4 graphs. All right, let's see. I'm going to set this up real quick. Let's go A here, B here, C here. Let's go A, B, C. Let's go A, B, C. A, B, C. All right, and now what the questions we're going to answer, I'm going to put them across the top. It's going to be a little smushed, but we'll be all right. A, I want to know the degree. B, I want to know the leading coefficient. I'm going to put LC. And C, I want to know the number of zeros. Okay. All right, now we're going to take this back. Before we really go into each one individually, we're going to take this back to the one we know. We know this one. Okay, or at least we know most parts of this one. This graph is called a what? Starts with a P. Parabola. Okay, parabola, good. Now, a parabola comes from a y equals x to the what? Y equals x squared. Okay, comes from y equals x squared. Okay. Now, notice the graph. The graph points, the arrows, mainly the arrows. The arrows point how? Up. On the second one, on number 2, the arrows point Down, but the direction that both arrows are pointing is up and down. See that? Okay. Both these arrows are pointing up. Both these arrows are pointing down. When that happens, your degree is even. Okay? Because 2 is even, right? Makes sense? So whenever your arrows both point up or they both point down, your degree, when we say it's odd or even, they are both even. Point in same direction is even degrees. Okay? This direction these arrows are pointing is what? Up. Alright, up. So what do you think as far as being positive or negative that tells you about your leading coefficient? It's positive. Over here, number 2, the arrows are pointing down, so the leading coefficient is probably negative. All right, now, who remembers what a 0 is? Not the y, the x, where you cross the x-axis. Okay, that is what a 0 is. I don't want you to figure out what they are. I just want you to tell me how many of them you have. So on the first one here, you have 2. The second one, you have 4. Okay? Now, here's the thing. All even degrees have the arrows pointing in the same direction. Whether that direction is up or down, and that's the only 2 you'll have, up or down. All even degrees, arrows point the same direction. So that's how you know they are even. Okay? If they point up, it's a positive leading coefficient. If they point down, it's a negative leading coefficient. Logically, right? The number of zeros can vary. It can be 0, it can be 2, it could be 4. It can't be odd, though. You will always have an even number of zeros when you have an even degree function. Okay? Logically makes sense, right? Because if you're going to go down, you got to come back up if you're going to be even. You might swirl a couple times in the middle like this one does. But eventually you got to go back the other way, so you're going to hit it an even number of times. All right, make sense? Let's move on to the bottom 2. Well, if these 2 are even, what do you think that makes these 2? Odd. You know how you can tell they're odd? They're going different directions, opposite directions. See that? This arrow's pointing down, this one's pointing up. This one's pointing up, this one's pointing down. That's how you know they're odd. Pointing in opposite directions. All right. Now, how do you read a book? Left to right. How do you read a graph? Left to right. Okay. From left to right, what's this graph doing? It's going up. Big girl words. Increasing. From left to right, this graph is increasing. What do you think that means about your leading coefficient? It's positive. This one from left to right is going down. Leading coefficient, you think, is negative. And then your zeros. How many zeros does number 3 have? 3. All right. One here, here in the middle, and then here. What about number 4? 1. Same thing. These zeros are case-by-case basis. Could be 1, could be 3, could be 5. They won't be what? They won't be even. Odd degrees have odd number of zeros. Because if you're going to start high and end low, or you're going to start low and end high, you always got to go an odd number of times. Look at this one here. We won't go up, then we turn back down. Well, if we're going to be odd and go back up, we got to cross that x-axis one more time. Okay. These can also go down, like you see how this one kind of goes down and then loops back up before it hits the x-axis. That can happen too. That's okay. Nothing wrong there. And then it goes all the way back down. It's page 258, 259. 27 through 31. Number 34, 36 through 39. Those last four, split them into three parts. The three parts we just did. A, tell me the degree. Whether that degree is odd or even. B, tell me the leading coefficient. Whether it's positive or negative. And then C, tell me the number of zeros. Okay? You will have a lesson check over both days tomorrow. All right, day 1 and day 2. Both are covered in this homework set. All right?